In 2011, a scanner in Texas powered on, and a Mastodon rib that had been sitting quietly in storage for 30 years suddenly lit up from the inside. There was something buried deep in the bone. Not a crack, not a natural spur of bone growth. A point deliberately sharpened, made from bone itself. And that rib was roughly 13,800 years old. That number is older than the first Americans were ever supposed to have existed. Someone had hunted this animal with a weapon, on a continent where humans supposedly weren't allowed to be yet. The man who originally dug that rib out of the ground had been called reckless for decades. He was about to stop being the joke of his field. Let me walk you through exactly what that scan revealed, because it's stranger than just a date. The object is a spear point, but it wasn't carved from stone the way most ancient weapons were. It was shaped from mastodon bone, possibly from the very same kind of animal it ended up buried inside. The tip had punched into the rib and lodged there. And here's the detail that changes everything about this story. The bone had already started to heal around it. The animal had been struck, and it lived on for at least some time afterward. That's not a fossil that simply fell into a hole by accident. That's a hunt. A human hand drove that point into a living animal roughly 13,800 years ago in what is now Washington state. Why bone survives, when almost nothing else does. Before going further, it's worth understanding why a bog like the one on the Manus farm was able to preserve something as delicate as a shaped bone point for nearly 14,000 years in the first place. Because that detail matters more than it might first seem. Most organic material, wood, plant fiber, even bone itself, breaks down relatively quickly once it's exposed to oxygen and the ordinary bacteria that live in normal soil. Under typical conditions, a bone left in the ground might survive a few thousand years before decay and mineral leaching destroy it beyond recognition. But waterlogged bogs work differently. The standing water in a bog cuts off the oxygen supply that decay-causing bacteria need to survive, essentially placing anything buried inside it into a kind of natural long-term storage. That's exactly why bog environments around the world, from Denmark's famous bog bodies to sites like Monteverde in Chile, keep turning up organic material that should have vanished millennia ago. The Manus site sat in exactly that kind of environment, which is part of why the rib and the weapon lodged inside it survived in recognizable condition for Gustafsson to find in 1977 at all. Without that specific waterlogged low-oxygen setting, this entire discovery might never have existed for anyone to argue about in the first place. Why that number was a problem. Now hold on to why that number caused such a stir. For most of the 20th century, the story of the first Americans was locked in place. The first people to reach the Americas were said to be the Clovis people, named for their beautiful, fluted stone spear points, first discovered near Clovis, New Mexico. They supposedly crossed over from Siberia, walked south through an ice-free corridor, and arrived roughly 13,000 years ago. That was the wall. Clovis first. Nothing human came before it. Textbooks said so, museums said so. Entire careers were built on top of that single assumption. And the Manus rib didn't just break that wall. It broke it with the wrong kind of weapon entirely. Not a Clovis stone point, but a bone point, something the entire field wasn't even looking for in the first place. What actually changed? Between 1977 and 2011, it's worth pausing to explain exactly what technology finally allowed Gustafsson's original claim to be confirmed, because the gap between his initial discovery and its eventual vindication wasn't really about stubbornness on either side. It was about waiting for tools that simply didn't exist yet. In 1977, if you wanted to know what was inside a solid piece of bone without destroying it, your options were extremely limited. You could try to physically expose the object by carefully chipping away surrounding bone, risking permanent damage to a one-of-a-kind fossil in the process, or you could rely on visual inspection and educated guesswork based on the exposed portion of whatever was sticking out. Neither option could give you a clear, non-destructive, three-dimensional picture of an object still fully encased in bone. By 2011, medical CT scanning technology, originally developed for looking inside living human bodies without surgery, had become sensitive and precise enough to be applied to fossil specimens as well. A CT scanner takes hundreds of thin, cross-sectional X-ray images and stitches them together into a complete three-dimensional model, allowing researchers to see the internal structure of an object in fine detail without cutting into it at all. When Michael Waters and his team ran the Manus rib through a scanner, they weren't relying on guesswork or a visible fragment anymore. They were looking at the actual internal shape of the embedded object, clear enough to confirm it was a deliberately worked point, and clear enough to see exactly how the surrounding bone had begun healing around it. That leap in technology, more than any change in scientific opinion, is what finally turned a 30-year-old disputed claim into settled, visible fact. A farmer's backhoe hits something hard. Go back to 1977. A farmer named Emmanuel Manus, everyone called him Manny, was digging out a pond on his own property near Sequim, Washington. His backhoe struck something hard. Tusks. He had accidentally uncovered a mastodon. Carl Gustafson, an archaeologist from Washington State University, came out to lead the excavation. And in that waterlogged bog, where bone that should have completely rotted away had instead been perfectly preserved by the wet, low oxygen conditions, he found the rib with something sticking directly out of it. Gustafson looked at it and said exactly what he believed it was: a weapon. Evidence that people had been hunting mastodons in this region around 14,000 years ago. The bog had kept the bone intact. The tool had outlived the hunter, outlived the animal, and eventually outlived almost everyone's willingness to take Gustafson seriously. Because in 1977, he simply could not prove it with the tools available at the time. His dating methods were older and less precise. He had no way to actually look inside the bone. He couldn't rule out the possibility that the object was just a natural fragment that had gotten jammed in there by chance. So the field did exactly what fields tend to do with evidence that arrives too early. It shrugged. Maybe it was a natural bone spur. Maybe the site had been disturbed. Maybe it was simply wishful thinking from a man who badly wanted his discovery to matter. For 30 years, the Manus site stayed a footnote, and Gustafson stayed known as the guy who had overread a bone. Here's what I want you to really understand about this. The objection wasn't stupid. That's the uncomfortable part of this whole story. The sediment layer had genuinely sealed the object in place. The date came directly from the bone itself, so if you wanted to keep the Clovis first model intact, you really only had two moves available to you: call the point natural or call the date contaminated. And calling it natural was simply easier. Easier to say out loud, easier to publish, easier on everyone's career. The easiest way to quietly bury a discovery isn't to destroy it outright, it's to make the person holding it look careless. A bog in Chile starts tearing down the wall. But one farm in Washington could always be dismissed as a fluke. One stubborn archaeologist could always be written off as simply wrong. The real problem for the old model was that Manus was never actually alone. Thousands of miles to the south, another site had already started tearing the whole wall down. In southern Chile, an archaeologist named Tom Dillahay had been excavating a place called Monteverde. And Monteverde was a genuine nightmare for the Clovis first model, because a peat bog there had preserved things that stone tools almost never leave behind: wood, hearths, worked plants, and even what appeared to be a human footprint pressed directly into the ancient ground. The date came back around 14,500 years old, older than Clovis, and this was happening at the far southern end of two entire continents. For years, Monteverde was attacked in exactly the same way the Manus site had been: too old, too messy. Must be wrong somehow. So in 1997, something genuinely rare happened. A panel of senior archaeologists, including some serious skeptics, flew all the way to Chile to see the site for themselves in person. They walked the ground, they examined the evidence directly, and most of them ultimately agreed. Monteverde was real. It really was that old. That was the moment the crack went fully public. But look at what it actually took to get there. It didn't take just one rib in a bog. It took an entire delegation of experts physically flying to the far end of South America before the field would finally admit the wall had a hole in it. Resistance wasn't the occasional exception here. Resistance was the field's default setting. And once Monteverde finally held up under scrutiny, every North American site that had been laughed off before deserved a second, more serious look. A rock shelter in Pennsylvania. Starting with a man who had been fighting since the 1970s, and who paid the price for it longer than almost anyone else in this story. In Pennsylvania, James Adovasio had been carefully excavating a rock shelter called Meadowcroft. Deep layers, painstaking digging, and dates reaching down past 16,000 years, possibly even further back than that. If those dates held up, this wasn't just slightly older than Clovis, it was dramatically older. The critics raised a genuinely real objection here, and this is exactly where honesty matters most. Meadowcroft sits in coal country. Groundwater moving through that kind of terrain can carry ancient carbon along with it. That ancient carbon can make a radiocarbon date read older than the actual object being tested. That's a legitimate scientific concern. Raising it isn't gatekeeping. But here's the twist buried inside that fair objection. A reasonable concern can also become a very convenient door, because as long as contamination remained even remotely possible, the old model never actually had to change. And Adovasio spent an entire career, decades of his working life, defending a single site against the exact same recycled doubt, over and over again. He wasn't just arguing for one date anymore, he was arguing against the entire shape of his discipline. The field didn't need a villain to slow him down, it had inertia. And inertia doesn't need to be cruel to quietly end a career one delay at a time. Human waste. That wouldn't wash away. What the old model really needed to finally be forced to change was evidence that contamination genuinely couldn't explain away. Something that couldn't have simply leached in through groundwater. Something that had, at some specific point in time, actually been alive. And unmistakably human. And in the caves of Oregon, that's exactly what turned up, at a site called Paisley Caves. An archaeologist named Dennis Jenkins was finding something most excavations never managed to recover at all: human coprolites, ancient human waste, dried out, preserved, and genuinely old, and inside them, ancient human DNA. The dates ran back to around 14,300 years. This wasn't a stone tool that skeptics could argue was simply natural. This was a person, their actual biology, left behind in a cave. The critics adjusted their argument. Fine, they said, but DNA is mobile. It could have leached down from younger layers sitting above. Water moves. Molecules travel through sediment over time. So Jenkins and his team went back and tested again. They controlled carefully for sediment movement. They sampled repeatedly. They checked the layers surrounding the coprolites in detail. Same answer came back. They tested it again. Same answer once more. That was the real problem for the skeptics. You can dismiss one single sample as contamination fairly easily. It gets a lot harder to do that when the cave keeps handing you the exact same date over and over, no matter how carefully you test it. But DNA is invisible in a very real sense. You can't put it up on a museum wall and make a general audience feel its weight the way you can with a physical object. What this whole argument still needed was tools, real, worked stone, sealed safely underneath the Clovis layer, in a place where nothing was supposed to exist at all, stacked tools underneath Clovis in Texas. And a site in Texas delivered exactly that, dug by the very same scientist who would later put the Manus rib into a scanner decades afterward. His name is Michael Waters, and the site is called Buttermilk Creek in central Texas. His team excavated thousands of stone artifacts, and they were found stratified directly below the Clovis layer, dated to around 5,500 years old. Think carefully about what below actually means here, because it's really the whole game. Clovis material sitting on top, older tools sitting underneath it, sealed in place by undisturbed layers of sediment. That's not something that could have simply fallen down through a crack by accident. You cannot drop artifacts through solid, layered sediment and have them land in such neat, older order below. The ground itself held those tools in place like a locked drawer, and that drawer was quietly saying that someone had been there first, long before Clovis ever existed. And notice the thread connecting all of this together. The same man scanning a Washington farmer's rib was also the man carefully stacking tools underneath Clovis layers in Texas. This wasn't just a scattered handful of unrelated oddities anymore. The same underlying evidence was showing up in different states, in completely different forms, all pointing toward the same buried fact. From did they beat Clovis to how. So the question in this field stopped being simply, did people arrive before Clovis? It became a much harder question. How? How did they get here this early and spread out across such an enormous range of terrain so quickly? And the answer sent researchers looking somewhere the old model had never bothered to check. Underwater in Florida, in the dark, tannin-stained water of the Osceola River, a team, including Waters, and an archaeologist named Jesse Halligan, was diving on a site called Page Ladson. Down in the riverbed sediment, they recovered a mastodon tusk, showing what appeared to be cut marks, along with a stone knife nearby. The date came back at around 14,200, 450 years old. Sit for a moment with where exactly that evidence was found. Not in a desert, not tucked inside a dry cave, underwater. Because when the last ice age finally ended, sea levels rose dramatically, and coastlines that people had once walked freely along went completely underwater. If the first Americans really did move southward along the coast, then a huge portion of their actual story isn't hidden away in some archive or museum basement somewhere. It's drowned, sitting underwater, where no skeptical critic can easily reach it, examine it, or simply dismiss it on a whim. This is a genuinely different kind of buried evidence. Nobody had to deliberately cover it up. The rising ocean did that work all on its own. A footprint. You can't argue. With every one of these individual sites, on its own, still gave a determined critic something to grab onto, a date to question, a layer to doubt, a mechanism to blame. But then something appeared that you simply cannot call a natural bone spur and cannot call a leached molecule. Something anyone at all can look at and instantly understand in about 1 second. In New Mexico, at White Sands, researchers found footprints, human footprints, pressed directly into the soft mud of an ancient lake shore, and then sealed in place by later layers of sediment. And the dates that came back weren't just slightly older than Clovis. They landed somewhere around 21,000 to 23,000 years old. That isn't a small nudge to the accepted timeline. That's a battering ram straight through it. And these aren't just abstract data points sitting in a spreadsheet somewhere. There are small prints, clearly belonging to children. There's a track that looks exactly like someone carrying a small child, setting them down for a moment and then picking them back up again. There are human footprints crossing directly over the paths left by giant ground sloths. This is a real person, standing on one specific patch of ground, tens of thousands of years ago, in a place the old model insisted was completely empty of humans. You simply cannot call a child's footprint contamination. The critics still had one genuinely real shot at this, and I'll give it to them straight and fair. The original dates came from the seeds of an aquatic plant, and aquatic plants can absorb old carbon dissolved in the water they grow in, which can push a radiocarbon date artificially too far back in time. That reservoir effect is a real, well-documented problem. For a while, it genuinely looked like it might sink the entire finding. So the research team went back and tried different independent methods. They dated pollen from land-based plants, which don't have that same water reservoir problem at all. They used optically stimulated luminescence, a technique that measures the last time individual sediment grains were exposed to sunlight, a completely separate and independent clock from radiocarbon dating entirely. And the new results landed in exactly the same ancient window as before. The objection that should have ended the entire argument got tested directly, and instead of holding up, it weakened. That's the real reversal at the heart of the story. The date itself didn't collapse under closer scrutiny. The doubt surrounding it did. How far does this go? And once the ladder of evidence reaches all the way back to 23,000 years, a genuinely unsettling question opens up. If it can stretch that far, where does it actually stop? Which brings us right to the very edge of the map, the claim most mainstream scientists still refuse to seriously engage with. In San Diego, at a site called Cerruti, researchers reported broken mastodon bones alongside heavy stones they interpreted as tools. The claimed age was roughly 130,000 years old. Let me be completely clear here, because this part genuinely matters. That particular interpretation is overwhelmingly rejected by the field. Most researchers believe the bones were more likely broken by heavy construction machinery or by ordinary natural forces, rather than by any human hands at all. This is not the answer to this story. This sits at the fringe edge of the entire debate, and it fully deserves the skepticism it continues to receive. But here's why it still belongs somewhere in this story anyway. Just 20 years ago, the idea of humans living in the Americas even 17,000 years ago was treated as something close to career suicide for any archaeologist who suggested it. Now, genuine footprints are pushing the timeline to 23,000 years and holding firm under repeated scrutiny. The old comfortable ceiling is simply gone. Cerruti almost certainly isn't real, but the fact that mainstream scientists now feel obligated to seriously argue about it, that all tells you just how far the ground underneath this entire field has shifted. When a wall falls, people start testing the edges. When a wall like this finally falls, people naturally start testing how far the field's boundaries really extend. So set aside the wildest, most extreme date for a moment. The solid, well-supported sites had already done the real damage on their own, and not just to the timeline itself, but to the entire proposed route people were thought to have taken. And that's where the whole traditional map genuinely stopped working. The old story absolutely needed that ice-free corridor, a gap opening up between the great ice sheets that people supposedly walked through, moving from Alaska southward into the rest of the continent. But study after study has suggested that corridor wasn't actually open and biologically livable early enough to have served that purpose. There wasn't enough food along the route. There wasn't a safe, passable corridor at all for a very long stretch of time. The road the textbooks had drawn so confidently may not have even existed yet at the exact point in time when these people were already clearly present further south. So researchers like John Erlandson started looking toward the coastline instead. This idea is sometimes called the Kelp Highway, a rich, unbroken ribbon of coastline stretching down along the Pacific, full of dependable food that people could have followed by boat, staying well fed the entire way south. It's currently the strongest explanation available for how humans managed to spread south so quickly and so early in this timeline. And it's exactly why this particular evidence is so difficult to find in the first place, because that ancient coastline is now sitting entirely underwater. Picture footprints already sitting on the far side of a river long before the bridge you happen to be studying was ever even built. The bridge, in this case the ice-free corridor everyone spent so many decades carefully studying, appears to have opened too late. The people were already across, which means they simply never used the bridge you can actually see and study today. The DNA makes the tidy story even messier. And then the genetics made the whole neat, tidy version of this story even worse. Modern genetic research now points toward more than one single founding lineage, not one clean, simple migration wave. There's a group called the ancient Beringians, identified from remains recovered at Upward Sun River in Alaska, who split off from other populations remarkably early. And stranger still, some indigenous populations deep in the Amazon carry a faint genetic signal that links, of all places, back toward Australasia. Nobody currently has a fully confirmed explanation for exactly how that particular signal got there, but it's genuinely real. It's published in peer-reviewed research. And it simply does not fit neatly into a story of one people, one migration wave, one single road into the continent. The old map, in other words, did not survive its first real contact with the full weight of the evidence. How a scientific model actually dies. So here's how a dominant scientific model actually dies in practice, not in some dramatic press conference. Nobody ever formally stood up and announced, "We were wrong for 50 straight years." Instead, the textbooks quietly softened their language. Museum labels grew noticeably quieter and more cautious. Clovis first slid, paragraph by paragraph, gradually into the past tense. The retreat never arrived as a formal apology. It arrived instead as a slowly revised caption, updated edition after edition. And this next part is what should genuinely bother you. Remember Carl Gustafson? The man laughed off for 30 long years over a rib pulled from a Washington bog. In 2011, Michael Waters and his research team finally put that rib into a CT scanner. The scan clearly resolved the shaped bone point buried deep inside it. New radiocarbon dating locked its age at close to 13,800 years old. Gustafson had been right. He had been right the entire time, and he was still alive to actually see it happen. Here's the twist that makes this story complicated, rather than simply clean and satisfying. The very same institutions that had dismissed him for decades were also the reason that rib survived at all. It sat safely in a museum collection, protected, carefully cataloged for 3 full decades, until the technology finally arrived that could prove exactly what he had claimed back in 1977. The field was simultaneously the gatekeeper and the archive. It buried the claim and it preserved the evidence, inside the very same building for 30 years. Nobody ever formally told Gustafson he had been treated unfairly. The field doesn't really apologize in these situations. It simply adjusts, quietly, and moves on. What we actually know now. So what do we genuinely know at this point? This part of the story is solid, settled ground. People were living in the Americas well before Clovis, Manas, Monteverde, Paisley Caves, Buttermilk Creek, Page Ladson, real sites with real, well-supported ages. And the footprints at White Sands are genuine human prints, pressed into genuinely ancient ground. Pre-Clovis is no longer some fringe idea sitting on the margins of the field. It is now the accepted baseline. This next part is still genuinely being fought over. The exact oldest dates involved, the full precise age of the White Sands prints, and exactly which specific route the first people actually took to get here. And this final part may honestly never be fully settled. Cerruti's 130,000-year claim almost certainly isn't real, and the coastline that might hold the very first chapter of this entire story, the actual beaches those earliest people once walked along, is sitting under more than 100 meters of ocean water today. You can't excavate it. You can't simply dismiss it either. You can't easily reach it at all with current technology. What this story teaches about science itself. Step back from the specific dates and sites for a moment, and there's a broader lesson sitting underneath this entire story, one that applies well beyond archaeology alone. Science doesn't usually change its mind all at once, in a single dramatic moment. It changes slowly through the patient accumulation of individual pieces of evidence, each one facing its own round of scrutiny, each one surviving or failing on its own merits. What makes the Manas rib such a powerful example isn't just that Gustafson turned out to be right. It's that being right in 1977 wasn't enough on its own. The evidence existed. The claim was made publicly. And none of that mattered until the technology caught up decades later, and until a wider pattern of similar discoveries at Monteverde, at Meadowcroft, at Paisley Caves, at Buttermilk Creek, at Page Ladson had already softened the ground enough for one confirmed rib to finally land as proof, rather than as another dismissible anomaly. That's an uncomfortable lesson in some ways. It means being correct is not always sufficient to be believed, and that timing, available technology, and the surrounding weight of other evidence often matter just as much as the strength of any single discovery on its own. But it's also a genuinely hopeful lesson because it means the scientific process, however slow and frustrating it can look from the outside, does eventually catch up to the truth, even when that truth sits quietly in a storage drawer for 30 years, waiting for someone to finally look again with better tools. Why a bone weapon mattered so much, it's worth spending a moment on why the material of this weapon, bone rather than stone, turned out to be such a significant detail in its own right, beyond just the date attached to it. For most of the 20th century, archaeologists searching for evidence of the earliest Americans were almost entirely focused on stone tools, because stone survives essentially forever, and because the Clovis point itself, the defining artifact of the old model, was made of carefully flaked stone. That focus meant an entire category of possible evidence. Tools made from bone, antler, or ivory was often overlooked or underexamined at older sites, simply because researchers weren't trained to expect it, or weren't looking for it as carefully. The Manas point forced a quiet shift in that thinking. It showed that early toolmakers in the Americas weren't limited to a single material or a single manufacturing tradition. They were resourceful, adapting their weapons to whatever materials were available and effective, including the bones of the very animals they were hunting. That flexibility suggests a level of skill and adaptability that doesn't fit neatly into the old, simple picture of a single wave of Clovis hunters carrying one standardized toolkit across an empty continent. It suggests instead a more varied, inventive population, capable of solving the same basic problem: how to kill a mastodon safely, in more than one way. The point is still in the rib. The point is still sitting inside that rib. It rests today in a museum drawer in Washington state, a carefully shaped piece of bone driven into a living mastodon by a human hand almost 14,000 years ago, healed over partway by an animal that managed to keep living a little while longer after being struck. For 30 years, it was treated as a mistake, dismissed, quietly filed away as a curiosity too inconvenient to embrace. Then, decades later, with the right technology finally in hand, it became undeniable proof. And even then, remarkable as it was only ever the very first crack in a much larger wall. The old story about the first Americans wasn't exactly a lie. It was simply too small. And most of what will eventually finish this argument entirely is very likely still out there right now, sitting quietly in storage boxes, buried in undisturbed sediment, or resting underwater in places that haven't given their evidence back to us yet.